Right. In this video, what I want to think about is the next stage in adding and subtracting algebraic fractions. So to show you what this next stage is, let's look at two examples. So example number one here is, I want to add a over 8 to b over 12. So I'm going to show you what we would have done last time, or the kind of approach we took last time, which is pretty much for all of the questions that we had, we made a common denominator and we made it by multiplying the bottoms of the two fractions together. So we just did whatever we had, a times b, p times q, 8 times 12, and in this case you would get 96. Now we can do that. You'd have to multiply the top and bottom here by 12. So you get 12a over 96, top and bottom here by 8, which is going to be 8b over 96. I'm going to make equal signs to make these line up, make them look neat. Add the tops, and I will get 12a plus 8b over 96. But the thing is, that's not as simple as it could be, because first of all, I could just divide the whole of the top by 2. In fact, I can divide the whole of the top by at least 4. What I'm going to do is I'm actually going to try and factorize the top to see what I can divide into it. So if I factorize the top, I can take out a 4 from the top. So I get 4 lots of 3a plus 2b, all divided by 96. I can see that I can divide the top and bottom by 4. Now again, this is quite cumbersome, but if I divide the top by 4, that becomes a 1. If I divide the bottom by 4, well, you've got to think about it a bit, but if you do think about it, turns out that 4 24s are 96, so that would be a 24. So the final answer would be 3a plus 2b divided by 24. So there's nothing wrong with that. If they said add these fractions and simplify, this is all correct. But it's cumbersome. It's cumbersome because you've got a 96 here, it's quite a big number. It's cumbersome because when you get down to here, you've got to factorize to kind of try and simplify again if you're asked to simplify it. And there's a way to avoid all of this difficulty. So if I just get rid of this, go back to the start, I'm sure you probably did spot, but if you didn't, you can see we could have chosen an easier denominator, an easier shared bottom piece for these fractions. So I'm going to choose 24. Right from the start, I'm going to find the smallest number, 8 and 12 both divide in 2. I'm going to multiply the top and bottom of the first fraction by 3. I'm going to multiply the top and bottom of the second fraction by 2. I'm going to go ahead and this is the answer we had last time. So it's 3a plus 2b over 24, but you get there instantly because you've basically chosen a nice easy, or the easiest denominator, the easiest bottom part that you can. So that's really what today is all about. It's about when you add and subtract fractions, just being careful about which denominator you choose for the fractions before you add or subtract. So for this one, again, we could choose a denominator of p multiplied by pq. It'd be cumbersome, but we could do it. But you can see, if I just multiply the top here by just q and the bottom by just q, I can turn both fractions into fractions with pq in the bottom much more quickly. So that's going to give me a final answer of 3q minus 2 divided by, make this a bit neater, divided by p times q, like that. And there's nothing more I can do to that. That's as simple as it can be. So let's do a couple of slightly harder examples. So these are kind of introductory examples, but the next pair will be a little bit harder. So let's say that I wanted to simplify this time. So we'll call this question 3, 5 divided by a squared minus 4 divided by 2 times a times b. Now, what I'm trying to do is I'm trying to choose a denominator that I can turn both of these into. In other words, I've got to be able to multiply a squared by something to get whatever this bottom piece is, and I've got to be able to multiply 2ab by something to get whatever these bottom bits are, and they've got to be the same bottom bit. Well, if you think about it, whatever this bottom bit is, it's got to contain a 2 somewhere, because 2 times whatever, when I say a 2, it's got to be divisible by 2. And the smallest, if you just look at the numbers and think about, I don't like using the phrase, but like the lowest common multiples of the numbers. So the smallest number that 1 and 2 both divide into is 2. So if I put a 2 there, that's probably going to be something that I can make. A squared and a, well, again, the smallest number they can both, the smallest expression using a, they can both be turned into is just an a squared. Because a squared, well, it is a squared, a times an a is going to give me 2a squared. And again, I'm going to need a b, because whatever I multiply this by, it's definitely going to end up needing a b on the bottom, and 2a squared b is something that I can turn both of these expressions into. So you kind of just think about it term by term. Think about the numbers. What do both the numbers divide into? What's the smallest thing they can both divide into? What's the smallest expression with a's, like a squared, a cubed, that the a terms can both go into? What's the smallest expression with b, like b squared, b cubed, that the b's will both divide into? Well, sorry, the single b will divide into, but whatever b terms there are will divide into. So that means that we're going to multiply the bottom here, multiply this fraction by this question mark. We'd be multiplying it by 2b. So we multiply the top by 2b and the bottom by 2b, and we would get 10b on the top, like that. For this one, well, 2ab we'd have to multiply by a single a. That's all we need to multiply by, a single a. So we've got to multiply the top and bottom by that, and that's going to give us 4a, like that. Okay. Then I can just subtract, and I'm going to get 10b minus 4a divided by 2a squared b. Now, one last thing here, which is, do take a look at the top and see sometimes these things will simplify further. So this is a simple expression, but if you look at the top, I could take it a factor of 2, if I could factorize that top and get 5b minus 2a multiplied by 2. And on the bottom, I would get a 2a squared b. And I could divide the top and bottom by 2. So I would get a really simple, neat little answer, which is 5b minus 2a, all divided by a squared b. And that's as simple as it's going to get. So, you know, there's quite a lot going on in this question, because you've got to choose a denominator, and then here when you get to the end, you can also do an extra step, and always look out for that. Just take a look and see if there's something more you can do. Just one little thing to notice, which maybe some of you did notice at the start. I could also do this question by, at the very start, cancelling out the 4 and the 2, making that just a 2 and making that just a 1. And that would have made everything quite a lot easier. That would have saved me a line if I'd done that, at least. Okay, so you can also look out for things like that. Okay, one more question. So, question number 4. Let's say that I'm going to simplify x plus 1 over 12 minus x plus 3 over 8, like that. So again, I'm going to choose a denominator. I'm going to choose something fairly easy. The easiest thing I can pick, which is going to be 24, because they both divide into 24. Multiply the top and bottom by 3. Again, put brackets around these like we said last time to make everything easy. 3 times x plus 1. So, nope, try that again. 2 times, my mistake, because I've got to multiply top and bottom by 2, minus 3 times x plus 3, got to multiply top and bottom by 3, equals, okay, I'm just going to add these together, like that. I'm going to multiply the top and bottom out completely. So 2x plus 2 minus 3x minus 9 all divided by 24. Okay, 2x take away 3x is minus x. 2 take away 9 is going to be minus 7, and divide that by 24. And that's the best we can do for that.